Okay, so for today, we have learned 4 types of inference or 4 methods of inference. We learned how to do a one sample Z test. We've learned how to do a one sample Z interval, a one sample T interval, and a one sample T test. We're going to look at a 2 sample Z interval for a difference in proportions. So hopefully you remember that a Z test is primarily for inference about proportions. Remember pizza, Z with the P, and the T test is always going to be about some type of population mean or the T interval. So difference between Z and T. Today we're going to look at comparing 2 proportions, and I've got an example that I'm going to kind of introduce the topic. I'm going to introduce a new distribution that's important for us to know how to do a 2 sample Z interval, which is what we'll do today, and also it's how to do a 2 sample Z test. So here's the scenario. The sport of soccer has been growing in popularity over the past 20 years in the US, but it certainly has a way to go to catch up with the rest of the world. So Miss Barbero wants to compare the popularity of soccer in the US versus Brazil. To make this comparison, Ms. Barbero took a sample of 100 Americans and a simple random sample of 100 Brazilians. 26% of the Americans in the sample claimed that soccer was their favorite sport, and 77% of the Brazilians claimed that soccer was their favorite sport. So what I want you to think about is Ms. Barbero wants to compare the proportion of Americans that believe soccer is the #1 sport with the proportion of Brazilians who think soccer is the #1 sport. So we're looking at 2 populations now instead of just 1, and we're going to try and compare those. So I'm going to write out what our 2 populations are and the parameters that we're interested in. Our first population, of course, is the US, and we're trying to estimate P, the proportion who believe that soccer is the #1 sport. So if we were looking at one population like this, then we would do one sample Z interval, or we do one sample Z interval to try and estimate what this parameter is. But we're not only interested in this one, so we're interested in Brazil as well. So this is the information we've been given. And we've taken 2 samples, 2 separate samples. You got to understand they're not the same sample because one's from Brazil and one's from the US. And we want to try and compare how different these 2 proportions are. So what we have to consider here is right now our best guess is that 26% of Americans believe soccer is their favorite sport. And 77% of Brazilians think that soccer is their favorite sport because Brazil, volleyball is pretty popular in Brazil, so it's probably not 100%. So what we really want to figure out though is these are 2 sample informations. So we have this idea of sampling variability where just because our sample is 26% doesn't mean the true population parameter is 26%. We'd expect it to be somewhere close as long as our sample is representative, but we can't say it's going to be exactly equal to 26%. So that's where this idea of the margin of error comes in. And so for us to make this comparison, I want you to think about the sampling distribution for each of these samples, okay? So a sampling distribution, as we've learned before, is when we take all possible samples and we plot the proportions from all possible samples. So in this case, we'd be taking all possible samples of size 100 from the US, and we would plot the proportion who think soccer is the #1 sport. So we'd expect it to be somewhere close to 26 because that's what we got previously, but it's not going to be exactly the same each time. So in order for you to understand how this really is going to work, I'm going to tell you what the true proportion is. So let's just go ahead and assume that we know what this value is. Now, in reality, if we knew the value, then we wouldn't be doing a Z interval. But for it to make sense for you, I want you to understand that let's just go ahead and say that the true proportion of US people who think soccer is #1 is 25%. So P is actually 0.025. And let's say that those in Brazil, the proportion is actually 0.80. So now that we know that, we can expect what the sampling distributions will look like. So I'm going to draw the sampling distributions for this scenario for the US and for Brazil right here in this space. So here is what the sampling distribution of p hat would be for Brazil. So remember, p hat is a sample statistic, and this distribution is really all possible samples. So it'll be multiple p hats here. I'm not going to draw all of them, just a reminder. So if you remember what we know about a sampling distribution, we know that this sampling distribution will be centered at Brazil's population proportion. So we know it'll be centered at 80%. And our symbol for this would be the mean, mu, of the sampling distribution of, and then I've identified the superscript B for Brazil. The shape of this distribution, I know it's going to be approximately normal because of the large counts condition. Large counts condition says if we have 10 successes and 10 failures, which in our sample, we had a sample of 100, and we had 77 successes, which means we had more than 10 successes and more than 10 failures. So I know it's going to be approximately normal. And then the last thing I need to know is what's the expected spread or the variation? And we can figure that out by using the formula for the standard deviation of a sampling distribution. And this right here would be our expected spread of this sampling distribution. So now this is the sampling distribution of p hat for Brazil. We need to do the same thing for the US, and then we can make these comparisons. Here's what the distribution of p hat for America would look like, and that's why I put an A here, p hat of A for America. We expect it to be approximately normal because, again, we had 26%, so that would be 26 successes, more than 10 successes and more than 10 failures, so it'll be approximately normal, centered at the true population parameter of 25%, and this would be our expected spread from this sampling distribution. Now, the reason I'm showing you this is because if we want to make comparisons, then what that means is we've taken a sample from the US and from Brazil, and if we compare them, or if I subtract them, because subtraction is the best, because if it's a positive value, it gives you some information. If it's equal, or if it's 0, it tells us that they're equal. And if it's negative, it tells us information about both of the population proportions or sample proportions. So what I want to do is I want to find the expected difference between these two distributions. So obviously, the expected difference is just going to be the mean of this distribution minus the mean of this distribution. And I've chosen to do Brazil first because I want to have a positive difference. It doesn't matter which one you do first, but I prefer to work with the positive numbers. So in this case, the expected difference is going to be 80 minus 25. And then we'll look at the expected spread of this final distribution as well. All right, so here we go. If what this distribution is right here, it's the difference between Brazil and America. So if I take a sample from Brazil, let's just say it's this sample right here, and I took a sample from America, let's just say it's this sample right here, and I subtracted those two values, then I'm going to get the proportion difference. Now, I like writing it proportion of B minus proportion of A, because that tells me which one came first. So just for this case, each of these p hats now is a comparison between these two samples. So this distribution is our expected difference between the samples from Brazil and the samples from America. And we expect the difference to be 80 minus 25. On average, it will be 55, which gives us some information. We expect Brazil to be larger than America because this is a positive value. If it's a negative value, that would mean that America had a higher proportion of people who prefer soccer or think soccer is the #1 sport. Now, that's our expected difference, but the expected spread is a little bit different here. The expected spread of this distribution is here and this one is here, but now we're combining both of these distributions together, which means we're going to have more variation, which is why I drew this as a little bit wider than these two, because you could get a low proportion and a high proportion, or you could get a low proportion and a low proportion and make these subtractions. And so there's a lot more outcomes because now I'm considering variation in both distributions. So that's why this distribution here will be more spread out. It has more variation because it's accounting for both of these. And so the formula for the standard deviation is adding the variances together. So it's quite simple. It looks like this. All we have to do is add these two values together under the same square root, and that will give us the expected spread of this third distribution, which is the sampling distribution of the difference between two proportions. And so I'm telling you this because in order to do a two sample Z test or a two sample Z interval, we have to use this distribution because this is the distribution that is making the comparisons that we need to know. These are just estimating one proportion, and this one is combining them. And so now we can create an interval to capture the expected difference. Now, in this problem, I've already told you the difference because I wanted you to understand what we're going to be doing in the future. And if they told us the true proportion was 25 and 80, then there'd be no point in us doing this because we know what the difference is. So this is the distribution that we're going to be using for all two sample inference regarding proportions. So let's take a look, or no. If we're to do a two sample Z interval, then the process is almost exactly the same as it has been before for a one sample Z interval. So think about what the formula was for a one sample Z interval. You take your point estimate plus or minus your margin of error. Usually our point estimate is just p hat. If it's a one sample, it's just p hat. And this is the formula, right? Margin of error is the critical value times the standard error of p hat, and p hat is our point estimate. But now we're using two samples. So our formula, we have to incorporate both samples. Our point estimate is our estimated difference between Brazil and America. So our point estimate is going to be the difference between the two samples that we've taken. And so this is what our formula is going to be for a two sample Z interval. Our point estimate is the difference between the two samples. It's still the same exact critical value, which is dependent on our level of confidence. Remember, if it's 95%, then we know it's going to be 1.96. And then our standard error, this is now this value right here. It's the standard deviation of the statistic of the difference between the two samples. But this should be an A, not a B here. So really, this is the crux of what I wanted you to learn. And I wanted you to understand where the formula comes from. It's from this distribution right here. So if you understand this distribution, it's pretty simple to move forward because it's the same exact process. We'll do state, but now in the state section, we're going to list the two population parameters we're interested in: proportion of people in America, proportion of people in Brazil. In the plan section, now we'll list out, we have to make sure that these two distributions are normal. And I say that because the only way this distribution, which is the one that matters, is normal is if these two are normal. So that's why we check the large counts for both of these to make sure that this distribution is normal. So now in the plan section, we have to check randomness, the 10% condition, and we have to check the large counts for both samples now. So from here, I want to pull up the notes and take a look at an example that's already worked out just so you can see what is expected when you're doing a two sample Z interval. So I'll pull up the notes here and walk you through this, and I'll have you do a problem on your own.